Hi everyone, welcome to today's video on solving problems using areas of circles. So like our last video, if you saw it, I'm actually going to go to a Math Antics YouTube video that explains the area equation pretty well, and then we'll come back together for practice problems.
The formula for finding the area of a circle is area equals pi times radius squared. Again, we can use abbreviations to make it shorter. A for area and R for radius. Now this is a pretty simple formula too. It tells us that if we know the radius, we just have to square it and then multiply that times pi to get the area. Okay, but what does it mean to square the radius? Well, squaring a number just means multiplying it by itself. For example, 3 squared just means 3 times 3. And 5 squared just means 5 times 5. And r squared just means r times r. So our formula is really just area equals pi times r times r. But we write it in the r squared form because it's more compact. Oh, and one really important thing to keep in mind is that r squared is not the same thing as 2 times r. That's a common mistake that students make when first learning how to find the area of a circle. And if we look carefully at both of our formulas, you'll see why. These two formulas have a lot in common. In each of them, you're multiplying pi by part of a circle to find either the circumference or the area. In the case of the circumference, you're multiplying pi times the diameter. And in the case of the area, you're multiplying pi times the radius squared. But do you remember the relationship between the radius and the diameter? Diameter is just 2 times the radius. So we could rewrite our formula for circumference like this. Circumference equals pi times 2 times r. Ha! Now you see why it's so easy to get confused. To find the circumference, you take the radius and double it. Then you multiply by pi to get the final answer. But for area, you don't double the radius, you square it. And that's a very important difference. To help you see that difference in action, let's find both the circumference and the area of this circle using our two formulas. The only thing we know about this circle is that the radius is 8 meters. Luckily, that's all we need to know. First, we use our formula for circumference. Circumference equals pi times diameter. To get the diameter, we take the radius and we double it. That is, we multiply it by 2. 2 times 8 equals 16. So the diameter is 16 meters. Then we multiply that by pi to get the circumference. Since this is decimal multiplication, I'm going to use a calculator. 16 times 3.14 equals 50.24. So that means that the circumference of this circle is 50.24 meters. Alright, now let's find the area using our formula area equals pi times r squared. Again, we start with the radius, but instead of doubling it, we square it. That means we multiply it by itself. 8 meters times 8 meters equals 64 meters squared. Then we multiply that by pi. 64 times 3.14 equals 200.96 meters squared. That's the area of this circle. As you can see, the result we get when we square the radius is very different from the result we get when we double it. And one of the most important differences is with the units of our answer. Doubling the radius just gives us the diameter, which is a one-dimensional quantity. So the answer we get from our formula for circumference is also a one-dimensional quantity. But when we square the radius, that gives us square units, which are two-dimensional. That makes sense because area is always a two-dimensional quantity. Remembering that will help you avoid getting these two formulas mixed up. The one that has the radius squared is always for area.
So that's the area formula, and you see how it compares and contrasts to the circumference formula. Now we're going to apply it to find the area of some circles and then also find the radius of some circles given the area. Okay, so before we move on to our first example, let's just quickly review the parts of a circle from our last video and then also with our new understanding of area. Okay, so I have this red line here. The red line connects the center of the circle to the perimeter or the circumference of the circle. what is that red line called? That's the radius, which again means the distance from the center of the circle to the perimeter of the circle. What's the word for the perimeter, or that outside purple part of the circle? Yeah, that's the circumference. Okay, then we have this blue line that goes across the entire circle and through the center. What is that called? Yep, that's the diameter. And now we have a new vocabulary word, which we're learning today. I mean, you've heard area before, but now we're talking about the area of a circle. So the area of the circle in this diagram is going to be that greenish part that I just colored in, right? It's the inside, all of that. It's two-dimensional, meaning, right, it's not just a line, it's not a point, it's both, it has like a width and a height. Okay, so this inside green part, that's going to be my area. And then, of course, as the video said, our area formula is going to be equal to pi times radius squared. I'm going to link a video that you can click on that explains where you get that formula from. It's really cool, but it's not essential, so I didn't decide to include it in this video. Okay? All right, so that's my area formula. Now let's use it. So question number 1 says, find the area of a circular rug with a radius of 3 feet. So let me draw that. We're told that the radius is 3 feet. That's all we're given, but that's all we need because we can just use our area formula. So again, the area formula says that the area of a circle is equal to pi times the radius squared, or as you might have heard it more oftenly referred to in 6th grade, to the power of 2. Okay? All right, so let's fill in, just like we did with the circumference, the information that we are given. We are told that the radius is 3 feet. Okay, so that means r equals 3. So I can rewrite my equation, my formula, but I'm going to substitute in 3 for r. When I substitute 3 in for r, this is what it looks like. The only thing that changed is that r position. Okay, so now I just need to evaluate that. I'm trying to find my area A, which is already isolated. It's already all by itself. So that's good. We don't need to do anything else to solve for it. We just need to figure out what the right-hand side is equal to. Okay, so the first thing, let's deal with this 3 to the power of 2. Exponents you always deal with first. That's the E in PEMDAS. So again, this means not 3 times 2. This means 3 times 3. It means you're multiplying 3 by itself, so 3 times 3. Okay, it is not 6 then. What is 3 times 3? Great, 3 times 3 is 9. So then our area is equal to pi times 9. Or the way you'll normally see this written is we'll put the 9 out front of the pi. So we could also write that as 9 pi feet squared. Okay, so that's the right answer. Remember, as he explained on the video, we need to have our unit squared, because when we're talking about area, we're talking about a two-dimensional thing. And then 9 pi, that's right, that's the answer. It might not help you that much because you're not sure what that actually is in terms of just a normal number, but that is the most accurate answer. But let's go a step further and use 3.14 for pi as our estimate, and then multiply to see the answer in a different form. So we can use 3.14 for pi, and we just need to do 3.14 times 9. So 3.14 times 9 is 28.26. So 28.26 feet squared is also the answer for the area of our circular rug. All right, let's look at one more example like this. Now we have example 2. Find the area of a circle with radius 4 inches in terms of pi. So this one I do want you to do a little bit more. So I'm just going to set it up, and then I'm going to have you try it, and then we'll go over it. So how we're going to go about finding the area is we're going to substitute in 4 for r, because when they tell us here that the radius is 4 inches, that's them telling us that r is equal to 4, and we need to evaluate this equation, solve this equation for a when r is equal to 4. Okay, and when they tell us to leave our answer to find the answer in terms of pi, that means they're looking for the exact answer. They want you to keep pi in it. So don't multiply by 3.14. Okay, just have some number times pi inches squared is going to be your answer. So it's like you don't need the last line on the example we just did. So go ahead, substitute in 4 for r, and figure out what the area of this circle is. Okay, good job. Even if you were stuck, good job trying. So our right answer here should be 16 pi inches squared. The most common wrong answer I already know is I bet at least some of you said 8 pi inches squared, because you correctly substituted in 4, and then you saw 4 squared, or 4 to the power of 2, and you said, oh, that's 8. No, it's not 8, because 4 to the power of 2, 4 squared, means 4 times 4. 4 times 4. So 4 times 4 is 16. Okay, so that's how I get my 16 here, and I just get 16 pi inches squared. Again, if they had asked not in terms of pi, then you could have multiplied 16 times 3.14 to get a good estimate, but this is the right answer that they're looking for. They want you to keep pi in it. Okay, great job, everyone. Now we're going to take it up a notch and try to find the radius when we're given the area. So for example 3, we want to find the radius of a circle that has an area of 78.5 centimeters squared. And they're telling us here to use 3.14 for pi. So we want to find the radius. So we do not know what the value of r is, right? That's what we're trying to find. But we're told that we have an area of 78.5 centimeters squared. That equals A. That is my area. So just like what I was doing before then, I can substitute that in for for A, keep the rest of the equation the same because that's the only information I was given, and then I need to try to solve this equation for r. Okay, so right now 2 things are happening to my r, and we're going to have to deal with those separately. So first, r is getting raised to the power of 2, or it's getting squared, and then r is also getting multiplied by 3.14. So we're first going to deal with getting multiplied by 3.14 because that's reverse PEMDAS. Reverse order of operations is how you solve equations. Right now, r squared is getting multiplied by 3.14. How do you undo multiplying by 3.14 or pi? Good, you divide by 3.14 or pi. So let's do that first. Okay, and when we do that, on our right-hand side, we have 3.14 divided by 3.14. Any number divided by itself is 1, so that's going to go away. And I'm just left with r squared on the right-hand side. 78.5 divided by 3.14 is equal to 25. So now our radius is not 25. What this is saying is when I take r, my radius, and I multiply it by itself, then I get 25. So I need to ask myself, what number times itself is equal to 25? You might know the answer to it. The answer is 5. So there's a few ways we can get that. Ideally, for a perfect square, this is called a perfect square like 25, you know that. You know that 5 times 5 equals 25. So if 5 times 5 equals 25, then what we call the square root of 25 equals 5. So this is a symbol that you've seen on the STAR assessment. I know people have asked me about a lot. This symbol comes up. So now I'm officially teaching you this symbol, which is exciting. So that's called the square root symbol, okay? And what that does is it's the inverse operation or the undoing of squaring something. So remember how I've been making it very, very clear this year that solving equations is about undoing what's currently happening to the variable. The reason I've been focusing on that is because that concept applies for the rest of your math careers, even when things get harder. So here, what's happening to my variable r is it's getting squared. How do you undo squaring something? And the answer is you take the square root of it. That's the inverse operation of squaring. What that means then, just like with multiplication and division, if you have r and then you square it and then you square root it, the squaring and the square rooting are undoing each other and you're just left with r. So it's like neither of those things happened, which is the point. Okay, and then on the left-hand side, we have to take the square root of 25, which, as I already said, is 5. So what you could do is if you have a calculator, or you could just go to Google, which is a calculator, you could type in square root of 25. And when you do that, it's going to tell you 5, right? So that's my answer. And again, the reason that is the case is because 5 to the power of 2, or 5 squared, is equal to 25. Thus, we get r equals 5. The length of my radius is 5 centimeters. Great job, everyone.